Okay, good morning. So let us start teaching the next part. Of course, this is not a new lesson. I would call it a little bit of recap of what you have learned in Math 1C. And if this is going to be okay, then we move to the other lesson, which is new. So I would recommend, I would try to solve some problems from the book to see that if that is okay with you. And if you know the topic fairly well, we don't spend so much time on it, we just move on, yes? So assume that you have this binomial. So here I have an expression including two terms. We call it a binomial, because of two terms. And then you want to multiply it by another binomial. So we know what to do, yes, from Math 1C lesson. So just multiply it using distribution rule, the law. So I multiply A by C, I multiply A by D, and then I multiply B by C, and I multiply B by D. Yes, this is at the algebraic level. You can also look at this from geometrical point of view. For example, you can consider a rectangle. So let me do it like this. So consider that you have a rectangle here. And then, for example, this part is A units. This part is B units. And then, for example, you have this C units and this D units. So if I ask you what is the height, what is the length of the height, of course here in algebra, A, B, C, D could even be negative numbers. But if you want to look at the same from geometrical points of view, A, B, C, and D should be positive. So I just want you to have a good idea of what is going on. So the height or the width here is A plus B, and the length is here C plus D. And if I ask you what is the area, you can calculate the area in two different ways. You can say that, okay, I have a rectangle, the height is A plus B, yes, and the length is C plus D. So I multiply them together, I get the area. Yes, so that is one way to calculate the area, which is of course the best way. But here you have an alternative way by partitioning your rectangle into smaller rectangles and calculate the area of each one of these partitions and add them up. You will get the same area again, yes? So what does it mean? It means that I draw a horizontal line here, and I draw a vertical line from this point. Then you see that I have now 4 rectangles that do not overlap. So it is clear that if I want to find the areas here, for example, let me call area 1, area 2, area 3, and area 4. So if I ask you the total area again, the area can be viewed in this way. I can calculate A1, A2, A3, and A4 separately and add them up. I hope that you agree that I should get the same number, yes? But if I ask you what is area number 1, if you want to calculate, area 1, this region is a rectangle again, but its height is B, its length is C. So the area 1 is just B times C. And when I go to area 2, the height here and here are the same, so this is B and this is D, so it becomes plus BD. And then when I go to A3, here I have a rectangle. This length is equal to this length, which is D, and this height is equal to this height, which is A, so it becomes AD. And finally, if I go to A4, you have A and C here, yes? It becomes AC. And then you see that that's exactly the same thing. So But of course, this is only working for positive values for A, B, C, and D. Okay, so that is very simple. But we have to do some exercises. I don't know, should I start with a very, very simple one because we have already studied that. Okay, so let me solve some problems from the course book, okay? Exponent to C. I don't know, for example, 2047, part F. I am supposed to expand. They have written multiply and simplify. Yes, I can use the word expand. Of course, in principle, you can expand without simplification, but implicitly in mathematics, when I say expand, I usually mean expand and simplify. Yes. So, this is 9 plus 2x, and I have 3x plus 4. So I want to multiply these two binomials. So according to the rule that I learned there, I take 9 multiplied here and there, and then I go to 2x and do the same thing. So 9 times 3x is 27x, 9 times 4 is positive 36, and 2x times 3x is 6x squared, and then 2x times 4 is 8x. And now you shouldn't stop here. This is expansion part. Simplification part is that you need to determine which terms are similar and combine them together. This one and that one are similar. So I myself prefer to organize the terms. It is not mandatory. I prefer to write a polynomial in descending order of the powers of the variable. So I will choose, this is optional, I choose to write 6x squared first, and then I combine these two, 27x, 8 more x added to that one becomes how much? 35x, and then 36. Then I will stop here. So that is the simplification of it. Okay, so let me solve another one. So 2049. Let me consider this case, part C. They have asked you to simplify, to expand this, or multiply and simplify. Yes? So here I have three expressions that I want to multiply. It's exactly, the rules are exactly like numbers. If I give you 2, 3, and 4, and I ask you to multiply this, find this product, you can multiply 2 by 3. I have seen students confuse sometimes this with distribution. They multiply 2 here and there. This is not correct. Be careful. 2 times 3 plus 4, then it is 2 times 3 plus 2 times 4. That is true. But if I have 2 times 3 times 4, I have to decide. I have only 1, 2, 1, 3, and 1, 4. So I multiply 2 by 3 if I want to. The answer becomes 6. And then I multiply the result by 4. It becomes 24. Or if I want to, I multiply 2 by 4. It becomes 8. And I multiply 3 by that. It becomes 24 again. Or if I want to, I multiply 3 by 4. It becomes 12. And I multiply 2 by that. It becomes 24. All these options are possible. You can do them, but you are not allowed to multiply 2 by 3 and 4. Be careful, don't get confused. So that is up to you. Here I have 3 expressions that I want to multiply. I told you that algebraic expressions are just numbers written algebraically using variables. So at the end of the day, x is representing a number. 2 plus x is also representing a number. The same is true for 3 minus x squared. So then it means that you decide, do you want to multiply this by that and get the result and multiply the result here? Or you want to multiply this by that, get the result and multiply it here? Or you can multiply these two, get the result and multiply x by that expression. That's up to you. And of course in algebra, in contrary to the numbers, I would say that sometimes it is better to think before multiplication. Here it doesn't matter that much in which order you want to multiply them. But here sometimes it matters, especially when we start learning about algebraic identities. So here, I don't know which one do you prefer. You say something, I follow you. Yes, Ali?
X and in parentheses 2 plus x.
Yes, so probably the natural order, yes? Yeah, why not? So this means that when I put equality, I have to respect the meaning of equality. So I momentarily ignore this, and I multiply this in here and there. So it becomes 2x plus x squared. Don't forget about the pair of brackets, and then you have to write the last one even if you are not doing something with it. And now what I do, I multiply once more. 2x times 3 is 6x. 2x times minus x squared is minus 2x cubed. And then 3x squared minus x to the power of 4. And I see that there are no similar terms involved, so I can leave it like that. But if I want to write it as an expression, I think, for example, if you use a software and ask, I don't know, GeoGebra to do it, I think automatically they put it in a standard form, I don't remember, but I think this is the way. Because they need to have an algorithm to do that, and probably natural choice. This is not a have to, so that's why let me change my color. So you really don't, you can't stop completely there, but I myself prefer sometimes to write it like this. I put minus x4 first, minus 2x cubed second, 3x squared at the third place, and this one the last. This is not mandatory. You can just stop there. Okay, so I don't see they have given you 3 complete brackets to multiply, but let us do that, okay? Just give you one example here. So what happens if I want to multiply x minus 1, 1 minus 2x, and x plus 2? So I want to multiply these 3. So again, the rule is the same. I think I don't see any priority here, so why not? Let us keep the natural order again. The first one multiplied by the second one, get the result and multiply it by the third. Yes? So what I do, I just follow this. I multiply this here, it becomes x minus 2x squared minus 1. Minus 1 times that one is positive 2x. And then I have x plus 2. That is up to you if you want to start another multiplication right away. But I have trained my brain in this way. For the human brain, it is better to start simplification first and then proceed, yes? So I myself prefer to simplify this result before continuing. So what I write x and 2x becomes 3x, and then I have minus 2x squared, and then I have minus 1, and then x plus 2. You can start multiplication right away and simplify everything at the end, which I don't recommend, okay? So here, I'm continue multiplication, so it becomes 3x squared, and then it becomes 6x, and then it becomes minus 2x cubed. And then I take this one and multiply it here, it's minus 2x squared. And then I take minus 1 and multiply it here and there, it becomes minus x minus 2. And that's also a good rule of thumb. How many terms are involved here? 3. How many? 2. 3 times 2, 6. So it means that before simplification, you should have 6 terms involved. If you see there are 5 terms, it means that somehow you have ignored something. You need to come back and check your answer again. So 1, 2, 3, 4, 5, 6. That's right. You have questions?
The third to last term.
Where?
The third, that one.
Yes.
Shouldn't that be 4?
Yes. Thank you. Thank you. Yeah. Please always watch me. Especially these days, I am moving to a new apartment on Saturday, so I'm really confused. So thank you. So 3x times that one, let us double check. It's correct. 3x times 2 is correct. Minus 2x squared times this, that is also correct. this one times that one, that is also correct. This, yes, correct. Thank you very much. Okay, and then I don't know which one do you prefer first. Yeah, it doesn't hurt. Let us write minus 2x cubed first. That is the only term involving cubic term. But I have two terms with x squared. 3x squared minus 4x squared is minus 1x squared, but I just write minus x squared. And then we have this term and that term, which is 5x. And then finally I have a minus 2 at the end. So that is the most thing that we can proceed. There is no way to go more unless you give me the number for x. Then I replace x with that number and then the calculation. Is that clear? Okay, let me also solve one of the problems in the book here. It is problem 2053. Let me choose part C. This problem is this. Simplify. We want to simplify this expression. Okay. Solving just this problem is not that hard, but I want you to understand what's going on so that you can, whenever the problem becomes complicated, you yourself should be able to understand how to proceed, yes? So how do you look at this problem? If I want to compare it, I would say that I have this combination. A number, A, is multiplied by another number. A number C is multiplied by another number, and then I am supposed to subtract it. So the structure that you see is important. Do you agree with me that the structure of the problem in the book is like this? Yes, I have two expressions multiplied here, two there, and then subtraction. So then, because the reason that I say I have seen some people start from difference and subtraction. I want you to understand. So I have two multiplications and one subtraction. Which one has the priority according to the conventions that we have so far? Multiplication. I have two multiplications. So in principle, people should use pair of brackets around them to prioritize. But instead of writing pairs of brackets all the time, people have used a convention. They say that, okay, when you see in a problem multiplication and subtraction are involved, give the priority to multiplication. And then, because of that convention, we do not need that one. So do not interpret it in that way, because you could, in principle, interpret it in this way, yes? By writing it in this way, you are prioritizing the subtraction over multiplication. So then the results would be quite different, yes? So this is not the correct interpretation. The interpretation is this. So when you understand the structure, follow the rules. So what should I do? I do this part. In parallel, I do this part as well. Yes? So if you don't mind, let me put a pair of brackets minus a pair of brackets. In this pair of brackets, I write the result of this product. In this pair of brackets, I put the result of this product. And it is essential, especially the second pair of brackets is really essential. If you don't do that, the answer will be different. So A times 3A is 3A squared. A times minus 4 is minus 4A. And now here, A times 3A is 3A squared. A times minus 5 is minus 5A. 1 times 3A is 3A. And then 1 times minus 5 is minus 5. Okay? I prefer to keep pair of brackets one more step. Can I simplify something here? Apparently no. So I just copy and paste the result. But can I simplify something here? The answer is yes, because they are similar. But don't forget to put the pair of brackets. Of course, I don't want you to write so much. If you are quick and you know what to do, you can just write them very fast. But I really warn you, I have seen many students make mistakes just taking minus sign for the first one. They usually don't respect to put the pair of brackets. Okay, and then I will simplify that. It becomes minus 2a and then plus 5. And now I want to remove the pair of brackets. By the way, what is the meaning of expansion? When I ask you to write and expand something, I mean write an expression equal to that one without having even one single pair of brackets. That is the meaning of expansion, yes? So it is partially done, but it is not fully done. Why? Because still I have a pair of brackets left. So, can I remove this pair of brackets? Yes, I don't need to be careful at all because there is no number or very negative sign behind that, so just remove it. But, can I remove this? The answer is yes, but then I have to pay close attention because this minus sign, many students just take it for the first term. It's not the case. It's minus the whole term. You see, if I ask you, you have minus 2 plus 3. If I ask you what is this number, because you say 2 plus 3 is 5, and then I have the negative, it's correct. It's negative 5. But look, if you just take the negative sign for 2 and write it in this form, the answer is 1, and they are not equal. But if you respect, when you take this pair of brackets away, multiply minus sign here and there, the answer minus 2 minus 3 is again minus 5, and they are equal. Yes? Yes.
The 5 is positive in one equality.
Yeah, thank you very much.
Negative in another.
Thank you. Yes, thank you. Okay, now I multiply the minus sign in, so it becomes minus 3a squared, and minus times minus is plus 2a, and then plus 5 again. Expansion is finished. Why? Because I don't have any pairs of brackets left. But simplification is left. So this one and that one are similar, and fortunately exactly opposite, so they are totally cancelled. But then this one and that one are also similar. Minus 4a minus plus 2a is minus 2a, and then I have positive 5. So that would be the final answer for this problem. I explained so much because I want you to understand, because they can design harder questions for you with a little bit harder structure. But you need to understand the structure and know how to proceed. Any questions here? Okay, let me just solve another type of problem. So here you want to solve equations. Yes? Okay. So let me solve some of these problems for you as well. So problem 2055. Let us solve first part C. The problem is this. Solve the following equation. Be careful. So when I say solve, in those problems that you see so far, we didn't have any equality sign in the beginning of the problem, yes? So you see, here, the problem is this one finished. You see, you do not see equality sign here. Yes? This equality sign, I put it myself. This was the problem. Here, this was the problem. But here, I am asking you to solve an equation. When you see this word, it means that you should expect a variable and an equality. Yes? So this is the equation. Y plus 2 squared, totally squared, minus y plus 3, and then y minus 1 equals to 0. So let me emphasize here, we are supposed to solve. Next session, I will teach you a rule called squaring rule. We will use that rule to write something for it. But for the time being, we haven't studied that yet. So it means that I have to do it in this way. Okay, so in solving an equation, I have to simplify the form of my equation as much as possible. So this means that I have to interpret, be careful, you are not allowed to write y squared plus 2 squared. Be careful, a plus b squared equals to a squared plus b squared, even though I mention it all the time, but still I see many students make mistakes. This is wrong. Yes, you will see that what is the correct answer later. But if you have a dot b squared, yes, that is correct. You can write a squared times b squared. If you have a over b squared, you can write, of course, a squared divided by b squared, but not for this one. Both of them are wrong. So if I want to expand this, what should I do? There is only one way at this moment for us to write it 2 times and multiply it. Because a number squared means that number multiplied by itself. And then I write this one. But I have to put equal 0 and go vertically. And then the structure on the left-hand side is exactly the same structure that you had there, yes? The structure is 2 numbers multiplied, then subtraction. So here, that's the same structure. So you follow the same rules, yes? So what I do, I open a pair of brackets for the result here, minus a pair of brackets for the result here, and then I put equal to 0. But then this becomes y times y is y squared, y times 2 is 2y, 2 times y is 2y, and then 4, 2 times 2. And here y times y is y squared, y times minus 1, 3 y's, and minus 3. But then simplify. So this becomes 4y plus 4. So you see, if you naively write the first one squared, you get y squared, that's correct. If you write this one squared, you also get 4, which is also correct, but you will not get 4y, which is necessary. So be careful about that. And then here, I will have minus y squared. These two will be plus 2y, and then I will have minus 3 equals to 0. And now I can remove the pair of brackets. Here I don't need to pay close attention, just remove it. But here you have to remove and multiply this minus sign, not just on the first term, but on all of them. So it becomes minus y squared minus 2y plus 3 equals to 0. And then this one and that one are gone. This one and that one becomes 2y. 4 plus 3 is 7 equals to 0. And then that's a very, very simple problem. So you have to make y alone. So this means that y is negative 7 over 2. Yes? Okay. I want to write one here on the board, wait for you to solve it, and then that would be the last problem today. Tomorrow we will talk about the next part of the lesson. So this lesson was more or less recap from what we had in Math 1-6. So that problem that I want to wait for you to solve is again problem 2055, but this time the last part, which is part D. So let me write it here on the board, wait for you 5 minutes, and then I will solve it, and then we are done. You start working on your own. So be careful not to mess it up, please, okay? I want to make sure that you really understand. Okay, so 3 times 2x plus 1, and then 4 minus x, and equals to 16 minus 16, and then you have x minus 1 squared. Okay, so I want to pause recording and then give you 5 minutes. People at home, if you are interested to work on the problem, please take notes, because when I pause recording, you will not be able to see the board anymore. I will pause in 30 seconds. Yeah, please pay close attention to all the details. So I pause recording now. Okay, I think time is enough for this problem. Did you get the answer? Not yet? People at home? No answers yet. Was it hard?
We can wait.
Okay, I can give. Do you have the final answer?
I don't think this is correct, but I just say that x is equal to the third root of 12 over 11.
Might be they haven't been careful in designing the question. I don't know. Is the quadratic term left at the end or no?
Yes. It's quadratic or cubic.
No, cubic is not possible.
No?
It's easy to see that cubic is not possible. Because if I multiply these two, I get a second degree at most. And if I multiply this by itself, then that also becomes a second degree. It's not possible to generate a third degree. That is for sure. But if they haven't been careful, you see here, this is quadratic term, because if the quadratic term survives, we can solve it, but we haven't studied that yet. And in this book, they haven't talked about that yet. How to solve a quadratic equation will be a very important topic of this course, but it comes later. So this is why they have been careful here, design the question in a way that you do not face with quadratic term. I don't know, have been careful here or not, apparently not at all. Because now I realize the quadratic term here will be cancelled, but the quadratic here will survive. Okay, sorry, I don't know, that is not my mistake, this is the book, because they talk about quadratic term later. Okay, anyway, at least let me solve this problem up to some point and see what the problem is. So this shouldn't be here in this part. Quadratic term is actually the lesson that will come in chapter 3, not here. Okay, let us try to solve the problem. First of all, what is the structure? I have three expressions involved. So let me this time keep 3, for example. It doesn't matter, of course. We usually use the natural order, but let me keep 3, then this time multiply these two. So this becomes 2x times 4 is 8x. 2x times minus x is minus 2x squared. And then I have plus 4 and minus x. On the right hand side, this structure I want you to understand. What is the structure there? The structure is this. A number, minus another number multiplied by c squared. I want you to see the structure on the right hand side here, what I have seen. A, in this case, is playing the role of this 16, and this B is playing the role of that 16, and then C is playing the role of x minus 1. I just try to understand the structure, algebraic structure there. So now, then if you see it so simple, then you don't get confused. Which one of we have 3 operations: subtraction, multiplication, and of course, raising to power 2, which is also a multiplication. Which one of these has the priority? There is a rule for that, yes? Should I do this one first, or power first, yes? Power. We have to do the power. After the power comes multiplication, after that comes subtraction. You shouldn't get confused. So it means that I know that I have to do this one first. But the point is that in algebra, We will learn how to do it later, but here at this moment, the only way that I can do it is write it 2 times and multiply it. So then I simplify things here. 8x and x are simplified, 7x, and then I have minus 2x squared plus 4. On the right hand side, which one has the priority? Now the structure is like this. A minus b times c times d. The structure that you see here is of this type. And there is a very simple thing that we know that the multiplication has the priority. So here I can write 16 minus 16, and then you multiply this by that. It becomes x squared minus x plus 1. At least you should be able to simplify it correctly, even though we will not probably be able to solve that. Oh, it's actually, I think it's correct, isn't it? Now, let us see how it goes. Okay, so multiply that here. It becomes 21x minus 6x squared plus 12. But before multiplying, I prefer to simplify. You can write it on top here. So this becomes x squared minus 2x plus 1. Now I understand. I think there is a misprint. I think this 16 should be 6, not 16.
Yeah.
In that case, it is possible to solve, yes? Anyway, but I haven't done any mistakes. Let me double check. Yes, it is 6. Sorry.
Oh, come on.
So it was correct in the book. It's coming from my side. Sorry for that. Okay, so that's good. I actually was able to catch it exactly on time. It doesn't mean that if this is 16, we will not be able to solve it, but we need more advanced tools to be able to solve that. Okay, and then everything is now right. Sorry for the authors of the book. Okay, and then I will have 16 minus 6x squared plus 12x minus 6. Now everything is correct. So here you see that I want to move the x's to the other side. So minus 6x when moved to the other side becomes positive 6x squared. Will cancel that minus sign. So I can just save time, just cross them over. But I want you to understand what is the meaning of crossing them over. I'm moving this to the other side. This becomes positive and they are gone. And then 21x, I move 12x to the other side. It becomes negative. It becomes 9x. And then what I have to do, I have 12, 6, 16 and 6. 16 minus 6 is 10. But I am also moving 12 to the other side. 10 minus 12 is minus 2. And then x becomes what? Negative 2 over 9. So that's the correct answer. If it were 16, you will be able to solve it, of course, but right now you don't know the formulas and the techniques, so that was not possible right now. And that was my mistake. Okay. Thank you. I have already updated the Google Classroom, so please do not waste your time. You have still time. Practice on that. And tomorrow I will teach one more part, and then probably we will continue. So I don't know how many topics are left from here. Not that much. So you be careful. You have to be prepared for the coming test probably. Of course, I will inform you well before the test comes. No questions? Thank you.